Hello everyone, and today we are going to be doing a practice system design interview question called Design LeetCode. We're going to be walking through this interview question step by step and solving it the same way that you would be expected to in a software engineering system design interview. We're going to start off by briefly going through the requirements of the problem and then doing a brief API design layout. We'll spend the bulk of our time doing the high-level design, and lastly, we'll go through some deep dives that you might see in an actual interview. If you want to practice this question alongside us in our interface or practice other questions that we have, feel free to check out our problem solver at systemdesignschool.io. Now let's get started. So the first thing we want to do is actually go through our functional requirements and also our scale for the system. Now, in a real interview, the interviewer may give you the functional requirements, or they may describe the system to you and ask you to pull the functional requirements yourself. For the purposes of this video and this problem, we're going to go through the already given to us functional requirements. So there are three of these. The first one is to be able to view problems. Our users should be able to view problem descriptions, examples, constraints, and then also view just a list of all problems on the website. Additionally, we want our users to be able to submit their solutions. They should be able to solve their coding questions by submitting their code and having it run against our built-in test cases to get the results. Now, lastly, and what makes this problem a bit more interesting is the coding contests. Users should be able to participate in coding contests. On LeetCode and other similar platforms, these contests are timed events that have a fixed duration of 2 hours consisting of 4 questions. The score is calculated based on the number of questions solved and the time taken to solve them. The results should be displayed in real time, and at the end, the leaderboard should show the top 50 users with their usernames and scores. We also want this leaderboard to be updated in real time. Now that we know what the general functional requirements are, we also want to know what the scale of the system we're working with is. So we know that this system should support 10,000 users participating in contests concurrently. There's going to be at most only one contest a day, and each of these contests is going to last 2 hours. Each user is going to submit solutions 20 times on average, and each of these submissions will execute 20 test cases on average. We also want our user-submitted code to have a retention policy of 1 month, after which it will be deleted from our system. Lastly, any assumptions we're making, the assumptions that we're going to make are that the storage space required for the solution of each coding question is 10 kilobytes, and the read-to-write ratio is 2:1. Now let's move on to the first thing that we have to enter ourselves, which is the non-functional requirements of the system. Now, if this is your first time practicing non-functional requirements and you're using our UI tool, what you want to do is click on the Don't Know How to Answer section, and it will actually pull up tips for each section of the interview, telling you some things that you should focus on and how you might want to approach it. So in this case, what are some things we need to think about non-functionally? Well, first of all, we know that we need the website to be accessible 24/7, which means we're going to need high availability. We were also told that the website should be able to handle 10,000 users submitting code concurrently. So we know that we're also going to need high scalability. We also mentioned that during a contest, we want our leaderboard to be updated in real time. So to do this, we're going to need our system to have low latency. Lastly, our user code can't break our server, and we don't want our users submitting malicious code. For this reason, we need to place an emphasis on security. Now, these are just a high-level outline of the non-functional requirements, and in an interview, you might be expected to dive into them deeper. But the reason we're doing this is because this is going to outline and frame our high-level design later on and the considerations that we're going to think about. So as you can see from getting feedback, we did hit all of the points that this question wanted, so we can successfully move on to the next question. So the next thing that we need to handle is the API development. So in this case, what are the external APIs that our system needs to handle in order to satisfy our functional requirements? So what we're going to do here actually is brainstorm what kind of API calls would we need. Well, the first one is we know for a fact that we need to be able to get all of our problems. So we're actually going to make a GET request. And in this case, what we're going to do is we'll come up with kind of an arbitrary endpoint value. Now, whatever you set for your endpoint URL doesn't actually matter too much as long as it's readable and the interviewer understands what you're going for. So we can call ours /problems. And if we really want to be fancy, we can even add in some query parameters like maybe a start range for the number of problems and an end range for where we want to end this. Now with the GET request, we don't actually need a request body, so we're just going to outline a response body. In this case, we want to get back our problems. So maybe we do something like this, where we have a list of problems, and each problem has in it an ID, which will be a string. It'll have a title, which is also a string, and then also maybe like a difficulty, like easy, hard, medium, and we can also call this a string. So again, there's no one correct way to do this. This is just a general way to map it out. Again, the most important thing is you just want your interviewer to understand what you're going for. So let's think of some other endpoints we might need. So we're able to get a list of problems, but now we want to get a specific problem and get the details of it. So this is going to be another GET request. And in this case, what we'll do is we will submit it to the problems endpoint, but specifically we want the problem ID that we are getting the details about. Again, we don't have a request body, so we need to think of what goes in our response body. And in this case, we don't need a list because it's just one question. And let's just brainstorm some of the things that might be necessary. So, like we said before, we have an ID, we're going to have a title, we'll have a difficulty, but there's also some additional things that you're going to get when you open the problem, such as the description, which we can make a string. Maybe we have some constraints, which will be a string. And if you've used LeetCode before, you'll be familiar with more things. So, maybe we have some examples, and these examples are going to be maybe a list. So it'll be a list where we have an, input and output. Both of these will be strings in this case. So you can really design these how you want, but I think this is enough for this problem. Now, another one that we're going to need is actually submitting code for a problem. And so this is going to be a post request. And what we're going to do this is it's going to be at the problems endpoint, excuse me, at a specific problem ID. And we're going to want to make a unique endpoint URL, so we'll actually call it submission. Now, what are we going to get in a response body for this? Well, when we actually make a post, we do want to get something back. So first, we definitely want to get the status back. We want to know if we had a success or a fail. So we can even put something like success or fail. Again, it's pretty open-ended. This doesn't actually have to run. We also need to get back, and this is an important part of the question, we need to get back our test case results. So we need to know how we did on our test cases. So this is going to be a list, and each one is going to contain the status of that test case. So was there a success or a fail? And maybe we can even say a success, a fail, or a timeout, because this often happens in problems. So again, we're going to keep this high level, move through this quickly so we get to the high level design, but this is just giving you a general idea of what you need to think of. And then the last thing we're going to do is have an endpoint for the contest. So we want to get our leaderboard for the contest, so we'll do another GET request. And we'll actually put this one at / contests maybe. And each contest is going to have a unique ID we can identify them by. And to make it very specific, we'll just put it at the leaderboard. Now, again, there would be a lot of stuff you might want to add to this if you were building a complex system. But to keep it simple, especially because in an interview you don't want to dedicate more than 5 to 10 minutes to this portion, let's just include a ranking, because that's really the important thing we have here. And the ranking is going to be a list of all of the users. So it should contain, the user IDs, which let's put as a string. And then also we want to know their score because this is actually how we're going to be ranking them. So there we go. I came up with kind of 4 different API endpoints. So we can click get feedback and see how we did. Great, so as we can see, we did a great job coming up with 4 of our endpoints, and our system is actually telling us that, these are some additional things that we could have considered. So this is a reason why it's great for you guys to check out this tool on your own and work through it, because this is the best way to get direct feedback about what you can improve on. So anyways, for the purposes of this video, we're going to move forward and get to the high-level design. But yeah, it's a great tool to figure out what you need to improve if you make any mistakes. All right, so now we're going to move on to the bulk of the interview, which is the high-level design. So the first one that we wanted to do, and the way that we're going to do our high-level design, by the way, is we're going to do a design for each of the functional requirements. And what I like to do personally, because it makes it easy for interviewers to follow, is we're going to start with the simplest one and build up upon our solution each time. So we're going to start with view problems, which we know is that our users should be able to view our problem descriptions, examples, constraints, and browse a list of problems. So in general, this is a pretty simple approach to build. The design for viewing our problems, we're going to use a pretty standard 3-tier architecture. So before I write an explanation, I'll actually visualize it. So for sure, in any system, we need a client. So we'll put a client on here, and we can even label it client. So we're going to have our client. We also definitely need some service that has all the logic for accessing our problems. And so we can add a service in here, and we'll call this problem service. And we also need a database that's going to be storing our problem data. So we'll add in a database. Forgot to add it. And we're going to call this one specifically, we'll call it our problem database. Now, it's always important to specify what kind of database it is, what kind of service it is, because you might have multiple different databases and services within each design. So let's connect these so we have our flow, just like that. And honestly, this is pretty simple, but it's a great way to start off, and we can build later from here. But honestly, this handles pretty much everything we need for a simple functional requirement like just viewing the problems. Now, we might want to explain further why we made each decision. In an interview, you would say that out loud and maybe write some stuff down. So I'll write some notes here. So what do we include? Well, we have a client. We'll say included a client, and then you can specify what it might be. So, this client will be sending HTTP GET requests specifically because we're getting the problems. So send HTTP GET requests. We also included our problem service. So we can say included a problem service, and we can explain what it is. So it's a backend service with endpoints. And we already covered our endpoints earlier. So you can always go back to that previous step and take a look at it if you're wanting to know what's going to go where and how to outline things. And then we also included a database, problem database, which stores problem data. Now, one thing that is super useful to do in any interview and that your interviewer will look for is if you can specify what kind of database it is. So in this case, we're going to want to go with a relational database because we can actually store the relations between questions. I just think it's the simplest to work with, and it is an easy to implement solution. However, you could definitely argue that NoSQL would be a great example here, so definitely feel free to go ahead and do that if you're more familiar with that and think it's a better solution. I'm just going to go with SQL and relational database because that's what people are most familiar with. And just like that, we have a general idea for how we would design a system to solve this. So we'll build on this in future functional requirements, but let's get feedback on this one right away. Awesome, so we got some immediate feedback. So we know that for the client, we've included our client component and we explained the GET request, that's great. For our problem service, we did a great job explaining that we needed it, but this feedback is telling us that maybe we should have specified the specific endpoints we were going to use. So we should have specified that we wanted an endpoint to list problems and an endpoint to fetch details of a specific problem. Again, the whole point of this feedback is this is what an interviewer might say to you and give you feedback during an interview. So you can kind of treat this like a mock interview that you can do at your own pace. And lastly, we did include the database, and it's nice that we specified what kind of database, but yeah, perhaps we could have also considered detailing some of the fields stored in the database. So again, things I could have included, and in a real interview, your interviewer would give you this feedback, and then you would follow up on it. But in the interest of time, we're just going to skip ahead to the next functional requirement. All right, so the next one we're going to be doing is submitting our solution. So as you can see, we carried our previous design forward, and that's because we're going to be iterating on this as we go. So submitting our solution is a little bit more complex, so let's dive into this. We want our users to be able to submit their coding questions and their code, and it's going to automatically run against built-in test cases to get results. So what do we need to consider here? Well, we should think back to what we said earlier when we defined our non-functional requirements. So we know that we're going to have 10,000 users participating in contests simultaneously, meaning that we can have 10,000 people submitting code at one time. Additionally, each person is going to be submitting solutions about 20 times on average, and each of these submissions is going to run against 20 test cases on average. So as you can see, we're going to have a lot of people running a lot of things at once. We have high concurrency, we need low latency. So this is where we really want to consider how we're going to design our system to handle this. So first of all, what is actually going to be handling the code? Well, we need a code evaluation service. So we'll add in a new service for that because we want to separate our code evaluation logic and our problem logic. Awesome. We also know that we are going to have a submissions database because, as we said before, we do need to store submissions for a period of time. And additionally, we do need a place where we're going to be storing our test cases and results. So let's add a new database. It's always good to separate concerns as much as you can. This is something that is really strong signaling to the interviewer that you have a good idea of how to design advanced systems. So we could do something like this quite simply. But this isn't quite going to cut it because, as we mentioned, we do actually have a high concurrency requirement, and we want to keep this relatively, has to have low latency, and the availability needs to be high because with so many people submitting things at once, we don't want it to crash and have a bunch of our users code not submitted because this is going to affect our contest score and lead to a bad user experience. So how are we actually going to handle a high volume of submissions efficiently and securely? Well, this is where something effective like a message queue can come into place. In this case, our message queue is going to act as a buffer between the submission process and our code actually being executed. So we might want to place this between our service and the database because what's going to happen is the queue is going to pull things in one at a time, and this is just a buffer that will prevent our service from being overloaded too much and crashing. So fortunately, this is a common component, so we can just place it in like that. Now, if you're not familiar with how a message queue works, I highly recommend brushing up on it because in an interview, your interviewer may press you on it and ask you to describe it in more detail. So we know that we want to add a message queue. Now, lastly, don't just build a solution aimlessly without thinking about what's actually happening. So we know here that clients are going to submit their solutions to the code evaluation service, which is going to push them to the message queue. And then what actually happens then? Well, they don't just go right to the submission database. We actually need something to execute this code. Now, again, you can really structure this how you want. I am just going to add some arbitrary code execution workers as our way of executing the code. Again, your interviewer only wants to see that you're actually thinking about this and that you've considered some of the trade-offs and design decisions you might have to make. So we'll put our code execution worker. Maybe we have two, so one of them doesn't get overrun. And we might want to bundle these together in some kind of container. So maybe I can bundle them like that. Perfect. So our message queue is going to submit it to there. It's going to run the code and then store it in our submission database. And just like that, we've come up with an expanded system that now also accounts for this part of our high-level design, the submitting the solution. So I'm going to quickly write our explanation in. I already said it out loud, but I'll write it in, and then we can hit get feedback and see how we did. All right. So I just quickly typed out some of the things that we touched on. Again, in an actual interview, you would say that alongside writing this out, but this is the best way to do it within the platform so you can get instant feedback on your own. So we'll submit our feedback and let's see what it has to say. Awesome. Okay, so we did a good job including the service to receive user code and initiate the evaluation process. One thing we could have considered expanding on is why separating this service from the other one is beneficial for handling compute-heavy tasks. So again, I mentioned this before. We want to separate these services. I just didn't type it in. For the message queue, so yes, we remembered to have a message queue, which was a good thing to include because it acts as a buffer. Again, maybe we could have expanded more on explaining how a message queue would handle traffic spikes and decouples the submission and execution processes, as well as mentioning that there's fault tolerance when we have a message queue. So again, didn't include these in the interest of time. But when you're doing an actual interview, especially the higher level you're interviewing for, you'll be expected to know a lot more about the inner workings of these components. Lastly, again, we did remember to include the code execution workers to pull the queue and execute the submissions, which is great. But again, especially if you're higher level, you would definitely want to describe the process of fetching test cases more, how it actually executes code, how it's going to be recording our results, why we need a sandbox environment for security and isolation, and maybe even picking a specific technology for this and justifying the choice over alternatives. So if you're applying for an entry-level role, you might not be expected to know all that, but especially if you're going for a mid-level and definitely for a senior role, you will need to include all those. Now let's move on to the last part of our high-level design. All right, so we are on to the final stage of the high-level design, which is our last requirement of doing the coding contest. Now, the coding contest is probably going to be the most complicated portion. And again, the higher level you are, the more in-depth you'd have to go. For the purposes of this, we'll try to come up with the simplest solution possible that's still effective. So you see kind of what you'd be expected to do in an interview. So we have our design carried over from the previous example. And now what we need to do is add the ability for contests to be participated in, which is where we're going to have, again, 2 hours of 4 questions. Users submit their questions and get a score. And then we're going to have a leaderboard that updates in real time and shows the top 50 users. So what we're going to do here is this is actually a pretty straightforward service itself, but we just want to figure out a way to integrate it into our existing system. So again, easiest thing to start with, we know that we're going to have a service. We can call this contest service. Again, just emphasizing that we're separating our backend logic. Now, what we want to do is actually get our results when the code is run. However, we don't need to build this system out entirely. We already have our code evaluation logic and our code execution happening in this area here. So all we really need is to pull the results from this to our contest service and display this on a leaderboard so we can connect those. And again, this is why you want to build these step by step, because you'll start to see how different pieces kind of connect together and work in one fluent system. Now, again, what is the main consideration we need to think here with our leaderboard? Well, we talked about how the results are going to be displayed in real time. So how can we implement something that is going to make our leaderboard update, have high performance, and actually process the data in real time? Well, a pretty simple way to do this is actually using an in-memory database for our leaderboard. So again, you can use any kind of implementation you want. But I think a great one we can use is something like Redis for storing our leaderboard. So what we're going to want to do is implement that. We can put that here and we can just call it our leaderboard. So this is our in-memory storage here. And what's going to happen is this is going to get the results from the code execution workers when they're done. And whenever the contest service is going to be updated, it's just pulling from this area here, just like that. So the contest service is going to pull from our in-memory database. And this is how we can ensure that we actually have fast real-time data processing. So again, you kind of get the gist here. We've kind of explained how we're adding this. We're building on our current system. And I'm just going to quickly go ahead and write this down so we can see some of the feedback and see maybe what we got right and what we missed. All right, so I typed a couple things in, just some things that we discussed from before, mostly just because I want a chance to get some feedback and see how we did. Again, in a real interview, you would be speaking more out loud. This is just the best way for us to get immediate feedback on what we talked about. So as we can see, we did a good job making sure to mention that we need a contest service for managing the contest. And also we did a good job of mentioning that we need an in-memory database for our leaderboard storage. We also did a great job specifically picking Redis for its real-time data processing capacities. And again, this might not be expected for juniors, but as you get higher along, you might want to mention more details about how Redis works. So for this case of sorting a leaderboard, we could mention how Redis supports our top N queries for ranking the leaderboard efficiently. Again, just things to think about as you go forward. But with that, we've kind of done a good job of coming up with a high-level diagram. So obviously this is an easier system design interview question. But again, if you're at a junior level, this is what you'd be expected to do. And if you're at a more intermediate or senior level, you'd be expected to hit some of those points that we skipped over, going into more detail on. And specifically, you really want to get into the deep dive questions, which we're going to get into right now. All right, so we're going to take a look at some deep dive questions. Now, again, if you're a junior, you might not even be asked deep dives. And if you are, the interviewer is probably going to hold your hand and walk you through them. But if you're an intermediate or applying for a mid-level role, you'd be expected to answer these alone. And if you're a senior, you'd actually be expected to automatically come up with the deep dives and answer them all on your own. So depending on the stage you're at will really inform how independently you should be moving through this. Now, let's take a look at the first one, which is how does the code evaluation service decide if a submission is actually correct? So there are, as with any questions, a million ways to handle this, but we just need to come up with a solution that we think works, and our interviewer might give us feedback on if they agree, maybe some extra considerations. Now, a simple answer for this one is actually just saying that we can decide if submission is correct by comparing the output of the user's code with what the expected output is. So, we can say that the submission is correct if the outputs match. And how would this actually work in our system? So the way that it's going to work is our users are going to be submitting their code, which is actually going to be run by our code execution workers. And our test cases, well, how are we keeping track of these? That's up to us to decide. I personally think an intuitive approach is for each test case to have an input file and an output file. And what we're going to do is we're going to take this input file, put these values into the user submitted code, and then whatever is the result of the user submitted code, we're going to evaluate that with the expected output. And if the contents of the user submitted code after being run match the test output file, then we know that this was successful and this test has been passed. And then we can return a success status code with it. So I'm just going to quickly write that down, and then let's get the feedback and see if that makes sense and other things we could have considered. All right, so I just briefly wrote down what we discussed, and let's see what the feedback for this is. Great, so as we can see, we actually did a great job answering this question. We hit all the points of mentioning how test cases are executed, mentioning that an output file is generated, mentioning that we're going to be storing these files in the database, And then also explaining our failure handling. So explaining that an output file should be compared with the expected output file and marking it correct if the outputs match. Now we could have gone into more detail saying, hey, if the outputs, don't match, this is incorrect. If the output takes too long and exceeds the time, then this is going to be a timeout. But I think that's implied. So we did a great job on this question as a whole, and this is kind of what you'd be expected to answer on this deep dive. So moving on to the next one, how do we ensure security and isolation in code execution? So the reason this is important is because, again, if users are able to run any code they want, what happens if they write malicious code and are sending that code into our system? So we need a way to isolate where this code is being executed and make sure it's secure so things don't get broken. Now, in our design itself, we already have provided some of this because we put the code executors in a sandboxed environment like a container. And containers already provide a measure of security and isolation because if the container goes down or has malicious code, it's kind of isolated and not touching the rest of the system. However, there are some things that we could do further to enhance our security. One thing that we could do is limit the amount of system calls that code can make. This is great because if someone is trying to, DOS the server or anything like that, it will automatically stop the code from executing once a certain amount of calls are hit. We also want to make sure that malicious code doesn't impact other user submissions who are submitting it at the same time. So there's a variety of things we can do. Like we mentioned, we can expand on resource limitation, such as limiting the number of calls that can be made, but we can also put limitations on CPU usage, memory, and disk input and output. We can add a time limitation for each code that's being executed, so malicious code can't run for a long period of time. We could run each user's code in its own separate container, providing user isolation, or even limit the network access at each code execution. So there's a lot of possible things we can do, and we can even do multiple of these things at once. So let's write some of them down and see which ones were a good idea and which ones we missed. So I wrote the things down that we touched on. Let's get the feedback and see. So as we can see, okay, we did a great job mentioning all of the resource limitations. Great way we can make sure that we are limiting any potential damage. And then also some of the isolation techniques. We did a good job of mentioning that we can use separate containers for users and also that we can do network isolation to restrict access. One thing we could have added, which is a good point, is that we could have had file system isolation to actually restrict file system access and make them read only. But again, these are just some suggestions and these aren't even all inclusive. Maybe you thought of something else that's a great idea. In an interview, when you're doing the deep dives, the fundamental thing is to say all of your thoughts out loud and most importantly, justify your choices. There's a million right answers as long as you can validate why you think yours makes sense. There is no reason that whatever you come up with wouldn't be correct. And if for whatever reason the interviewer has a problem with it, they'll voice it back to you and you can kind of work through it together. All right, so I'm going to work through one more deep dive in this video. If you want to do the rest of them, again, feel free to check out the website for yourself. The link is in the description. But we're going to be doing the last one, which is how to implement a leaderboard that supports top and queries in real time. So we touched on this when we implemented our Redis in-memory storage earlier, but what we want to do is come up with a way to basically query our leaderboard so that we are constantly, sorting it and making sure that the top 50 are actually ranked in the correct order. Now, we have a few possible solutions here. We can potentially do our Redis solution from earlier. So using an in-memory data structure storage is great because they automatically come with a sorted set data structure for maintaining scores. Basically, each user on our leaderboard is going to be a member of this set, and their score is going to be used as the sorting criteria. So Redis already has these built-in capabilities. Now, let's justify why this might be good or might not be good. So what are some of the pros of using this? Well, Redis is going to have extremely fast read and write operations. It's also going to provide built-in ranking and range queries. And Redis is very scalable and can actually handle quite high concurrency. However, there are some drawbacks that we should consider. Because it's in memory, the data is volatile and it's going to require some advanced persistent strategies. And we might require some additional infrastructure setup to make this work. Overall, I think this is a very suitable conclusion and a definitely viable approach that we could implement, but let's brainstorm some other ones just to make sure that we're covering all our bases. So what if instead of using, Redis, we used a NoSQL database? So some kind of document-based storage like MongoDB. In this case, we might be storing our user scores as documents. And we're going to, again, index on the score field, and we're going to use some database-specific querying for any of our leaderboard operations. So the pros of this is that NoSQL databases have good scalability, flexible schema, and they can handle like a large amount of data. However, there are some drawbacks to this too. The biggest one is that they are eventually consistent, meaning that they might not be as suitable for real-time updates. Additionally, you might need to write some more complex queries compared to just a regular SQL database. This is also a viable solution, but I don't think it is explicitly better than Redis. So again, we're going to stick with Redis as our best solution. There are other ones you could explore too, such as using, any other kind of in-memory data structure. But because we kind of went through the pros and cons of Redis, I think that is a good one to go with. So let me write that down and we'll get our feedback. So we wrote down some of the things we discussed, and let's get our feedback and see if the system agrees. So we did a great job mentioning how an in-memory database like Redis can be efficient, but potentially we could have expanded on how frequent leaderboard updates could be managed effectively from a technical perspective, and also maybe explaining a strategy for handling top-end queries, something like using skip lists. And there we have it. We've actually gone through and completed this problem completely. We went through all the functional requirements. We built out a reasonable set of APIs. We built out our entire high-level design and justified all of our decisions. And lastly, we actually expanded on some of our deep dives and really honed in on some of the more technical aspects that you might need to consider. Now, this is by no means a comprehensive interview. Every interview is going to be different, but the whole idea is that you should be watching a lot of these videos and practicing a lot of interviews of your own so that you get a better feel of what you're meant to do. The best way to improve at system design interviews is to practice a ton. I really recommend watching a bunch of these videos. We're planning on making one for pretty much every possible system design question. And then once you feel like you have a good grasp of what's to be expected, then you should dive into the website and start practicing them yourselves. Thanks so much for watching. Make sure you subscribe and check out our website at systemdesignschool.io, and we'll see you in the next video.